Greetings. The topic for today is something that is very, very profound and very, very challenging, and therefore we're going to edge into this topic very gradually over multiple videos. This is a topic that many people are not even close to being able to conceptualize, and in some cases may offend even the religious sensibilities of some people. But nonetheless, we're going to talk about the evolution of intelligence. Now, the image that you're seeing here is an X-ray of a human skull and an X-ray of a chimpanzee skull, and the image of the brains of each is superimposed on that. And as you can see, the two are very different. The chimpanzee happens to be the closest relative to humans that exists, and we have a common ancestor from as little as 5 million years ago. And a lot of people are very fascinated to see how intelligent a chimpanzee is. And a chimpanzee is capable of demonstrating the same intelligence in terms of addition, subtraction, and cracking problems as a human child age 6 or so. But to me, that's not what's fascinating. What is fascinating is how large of a gap there is between us and our closest relative. As you can see from this image over here, a chimpanzee has much more powerful jaws than a human and a much smaller brain, whereas a human is the opposite, much weaker jaws and a much larger brain. So how can the chimpanzee be the closest related creature to a human when the difference in brain size is really that much? And the physical body size of a human and a chimpanzee is roughly the same. Remember, contemporary humans get much better food and are much larger than pre-19th century humans. Before the 19th century or so, or even before the 20th century, the average human male adult was 5 foot 6 inches tall and maybe 130 pounds, which is about the same size as a chimpanzee male. So the two are the same size under similar conditions, let's say. So why is there such a big difference in brain sizes, and what are the costs of this large brain size? For that, we briefly go to the very beginning of evolution to give some idea of the accelerating rate of evolution, particularly of intelligence. This image is a timeline of evolutionary periods, or geologic periods as they call it, but geology is not subject to the accelerating rate of change, whereas evolution, and certainly the evolution of intelligence, is. So it's a little bit inaccurate to call them geologic periods because that removes the most profound dimension of how these eras are categorized. In this left axis over here, where you see my cursor, you see 4.5 billion years of evolution and how almost nothing happened for the first 4 out of those 4.5 billion years, so the first 88% of the time. And only at the start of the Paleozoic era was there an explosion of life that we call the Cambrian Explosion. And so this small segment of just 540 million years to present is exploded out into more granularity. And you have the Paleozoic era, the Mesozoic era, most of which was occupied by the dinosaurs, and the Cenozoic era. And within the Cenozoic era, which started 66 million years ago, you have the Tertiary period, which is effectively the pre-human period, and then the Quaternary period, which is a very, very thin sliver even of this. So now we're talking about just a few million years from the present. And for that purpose, I now go to this next image. Now let me explain this chart because it's very, very profound. You have a common ancestor between humans and chimpanzees, which is called Sahelanthropus, and this horizontal axis starts from 0 and goes leftward 1 million year per tick mark, back to 7 million years ago. Now, if it went all the way back to the beginning, it would go several kilometers to the left, all the way back to 4.5 billion years. So you would need 4,500 of these units to extend this horizontal axis leftwards until the beginning of life. But starting just 7 years ago, we had a common ancestor with chimpanzees, Sahelanthropus, and then chimpanzees kind of stagnated at that level. And then you have a descendant of Sahelanthropus called Australopithecus, which is considered the first true ancestor of humans, which of course is now extinct. And then you get to more advanced humans like Homo habilis. But now you see the knee of the curve. Something profound happens, and the entire curve goes vertical in a very short time. In just 1.7 million years, we go from Homo habilis to modern humans. Homo habilis had a brain of a certain size, then Homo erectus, and then the two modern types of humans, the Neanderthal and Homo sapiens. So only 7 million years to go from Sahelanthropus to humans, and only 2.5 million years maybe to go from a 500 cubic centimeter brain to a 1500 cubic centimeter brain. And if you take an actual snapshot of an evolutionary intermediate step, you see Homo habilis to modern humans, only 1.7 million years to go from this creature all the way to modern humans that we are today. So why did this accelerate so quickly? As I said, if we extended this chart leftward, much further back in time, it would be a completely flat line. This is very exponential. It is not a linear evolutionary trend, and that shows that this is inherent to the software of evolution and the software of life itself. So humans are so much more intelligent than even predecessors from a short while ago in an evolutionary sense, and that's why a human has a brain that is 3 times larger than that of a chimpanzee, even though the body size is about the same. This is a singularity of sentience, let's say, that has already occurred. But then what does the future hold? Science fiction often portrays super intelligent aliens as having a gigantic head in proportion to their body, and people who can only think in terms of extending current trends assume this is what humans of the future might look like. But I guarantee that is not the trend line of evolution that humans are on. The human brain has already reached certain biophysical limits. The human brain, even though it's only 1 to 2% of a human's entire body weight, it consumes 20% of all a human's energy and 20% of all the oxygen that a human consumes. Similarly, the brain is so resource intensive that everything else about a human had to be downgraded. Humans don't have sharp claws, they don't have sharp teeth, they don't have powerful jaws, they don't have fur, they have relatively thin skin. A human being is a very fragile animal compared to other animals of similar size. A human with no weapons would lose a fight very badly against almost every other animal of similar size, because all those other attributes had to be downgraded to divert resources away from them and towards the brain. The brain has become something where a disproportionate share of all of the physiological resources of a human go, and no other animal has so much devoted to their brain. No other animal of similar size, at least. And furthermore, the human brain is so large that when a human infant is born, you have to have the 2 bones of the cranium fold over each other just so that the head can be compressed to be small enough to pass through the mother's pelvis in order for the human infant to be born. Other animals don't have that. So the brain is already reaching all sorts of biophysical limits, and it cannot become any larger in relation to a human body size. You won't have humans of the future with a head twice the size of the current head, whereas the body is smaller at all. That is just not possible in any way, shape, or form for all the reasons I mentioned. So how does the trend line of intelligence accelerate from here? Well, imagine I had a chart that was only a short amount of this time scale. So keep the vertical axis about the same, but shorten the horizontal axis to a much smaller scale over here. What will happen is that technology is something humans are getting more and more embedded with, and humans are interfacing with. You're using Google search several times a day, and that's why there's 30, 40 billion Google searches every day. The interface between humans and technology is still very primitive, but over time this interface will become more and more seamless, and humans will be able to draw upon various types of intelligence and various types of cognitive augmentation as needed. They won't have to be on all the time, but if they need a certain type of intelligence, they can ramp up to that. If they need another type of intelligence, they can ramp up to that and turn that off when they want downtime or they want to perhaps go idle for a short while. And these interfaces will become more and more tight, as I'm saying, and that is how the trend line of intelligence will extend. Humans will be able to draw upon super intelligence that exists outside the human body with much better interfaces than exist today. In fact, I'm connected to a company that is working on just this and will have very advanced interfaces for doing this, but that company's plans are still in stealth, so I'm not going to disclose too much about that right now. And that's why what we will see here in a much shorter time scale is you'll see the human metric of intelligence, which, as I said, is no longer going to be cubic centimeters of brain size, as a flat line for now, the 2020s, the 2030s. And by the 2040s, you'll start to see an uptick, and it'll get very, very steep by the 2050s and nearly vertical by the 2060s, resulting in a technological singularity, which of course I estimate to be by around 2062, give or take. So these interfaces of superintelligence with the human brain are what will make this intelligence trend line go higher and result in the metric of measurement no longer being the cubic centimeter volume of brain size. And that's how you get a complete merger of human intelligence with artificial intelligence, and therefore a technological singularity. Now, I have said for many years in a lot of my writings that humans are just the precursor, the boot drive of an eventual superintelligence. And Elon Musk has said the same thing, but he said it many years after I did. I hope someone who read what I wrote told him about it and then it happened that way, but I have no way of knowing that for sure. But this is the most probable trajectory that the continued evolution of intelligence is going on, because this trend line has never ever broken. People who say humans are an accident or humans are the end of evolution, they really don't know what they're talking about because they don't understand technology. The answer is for faster improving, more energy efficient types of intelligence to be seamlessly drawn upon by humans as needed by the human in question, so the human can access higher intelligence for themselves when it's needed and not access it when it's not needed. And there are already companies working on that, as I mentioned. So this is a very, very profound subject, and we're going to talk about this in other ways over the course of this channel, but some food for thought for sure. Now, if you like this type of content, I encourage you to subscribe to this channel, and thank you very much for watching.